Welcome to the Singapore Cloud and Data Center Convention 2024. Our next speaker is Ed Ansett, the chairman of i3 Solutions. Ed will be sharing his expertise on a crucial topic, strengthening data center infrastructure, key insights, and strategies from recent outages. With his extensive experience and deep industry knowledge, Ed's insights are invaluable for anyone involved in data center operations and management. Please join me in welcoming Ed Ansett.
Welcome. My name is Ed Ansett. Of course, it's lovely to be back. I've missed a couple of years here, so it's fantastic to be back and see everybody. We're going to talk about data center failures. Now, the problem with this topic is that every project you do is subject to a non-disclosure agreement. And certainly every data center failure that you investigate is subject to a non-disclosure agreement. So when I was asked to talk about this, I thought, how are we going to do this? I think the best way to talk about this is to talk about recurring failures, groups of failures, types of failures that we see frequently. Just so those of you that don't know me and i3, most of the work we do is greenfield design or brownfield design, but we also do a lot of investigative work, sometimes forensic work. Root cause failure analysis is something we spend a lot of time doing over the years, and so this is where all this information I'm about to provide is kind of based on stuff that we have come across in the past. As I said, we're going to talk about different failure. What I've done is I've categorized failures into sort of groups. So some of you will be familiar with these types of failures. The first one is the high-pressure fire suppression discharge problem and the impact that has on hard drives. Now, most people are aware of that. Perhaps they're not aware of what the solutions are. Then we're going to talk about a subject called N-1 generators. And what the heck is N-1 generators? That can't be right. Well, I'll come to that in a minute, and hopefully you'll understand why I've called it N-1 generators. But again, it's a recurring cluster of problems that we see that result in data center failures. I'm also going to talk a bit about STS, that static transfer switch transformer core saturation, which has been going on for many years, but still it seems there's not a very high level of awareness of this problem. Cyber, how could we have a discussion like this without talking about cyber? So we're going to talk about that. Arc flash, seen far more arc flash instances, particularly over the last couple of years, than we've ever seen before, so that's a problem. A little bit about EOPS, emergency operation procedures, and then software. And the good thing about the software topic is you don't have to worry about it if you're power, cooling, controls engineer, but it's still a major failure category. So before we jump into that, what do we know about failures? You guys, I don't think many people carry out the FAMIA assessment of their data center design before they go into production, but I personally would argue it's quite an important thing to do, because a failure modes and effects analysis allows you to look at the whole system in its entirety, every single, not going to say every single component, but almost at component level, subsystem, system level, and integrated system level, and say, okay, if this fails, what's the knock-on effect? How does that impact the performance of the data center? Does it cause it a problem? Does it impede performance in some way? Does it cause an outage? So it's a powerful tool. Now, just to give you an idea of the complexity around that, and it is a long and tedious exercise, I'm embarrassed to say, but I'm going to say about 20 years ago, I did a study of a simple motor circuit. You can see there were 7 devices, only 7 devices. So you've got a motor, a starter, which are fed via cable, an MCB, which in turn are fed by an MCCB and a board above that. So there are 7 devices, and there are 20 failure modes associated with those type of devices. When you do the maths, you end up with many, many thousands of possible failure combinations. It's a bit like when you play chess and they say, I can't remember the numbers, like after 3 moves, there's umpteen million alternatives. It's that complicated. But the good thing is, for the most part, most of these failures are either mutually exclusive, which means they really can't occur at the same time, so they're impractical. You won't get, for example, a cable go open circuit, short circuit, and have an earth fault at the same time. And some of them, that's unlikely to coexist, and some of them are mutually exclusive. So you won't have a motor that fails to start and then fail to run after starting. So you can eliminate. But even for that simple circuit there, you're still going to end up with about 100 failure scenarios. And then you think about the data center itself and how many of such circuits it's got and all the other configurations that exist within a design, and you're talking a huge number of failure scenarios. Bit of a problem, really. Failure is best, well, it can be done in quite a few ways, but typically the way we would do that is to look at what the failure mode is. So pick the failure mode, what would cause that, what will be the impact, the immediate impact, what will be the knock-on impact, look at the severity, and look at the probability of it happening, look at detectability. Some failures are more easier to detect than others, and then ultimately look at the mitigation of that failure. So that's FMEA. So let's get into the failures, the actual sort of failure modes that we're talking about. So hard disk drives and fire suppression systems. So hard drives, yes, SSDs, solid state drives have definitely definitely helped this problem. You don't have the same problem with solid state drives as you do with hard drives. But hard drives are susceptible to noise. Now, the exact amount of noise is not clear, but give or take, is about 100 decibels. So when we've got a fire suppression system goes into discharge, typically this would happen, and this has happened many times. You got a piece of faulty IT equipment that smokes, generates two detectors are activated, and the gas is discharged, resulting in a failure of the data center. So the system discharges. Loss. I'm trying to think about how many. So there's 3 or 4 of these instances. So what do? How can we deal with that situation? Well, basically, apart from switching to SSDs, the other alternative is to look at attenuating nozzles. Well, that helps. Another way is to use attenuating nozzles and to reduce the amount of pressure in the gas discharge. So that's one category. Another problem now is N-1 generators. And what might that be? So here's the scenario. This happens to be a pneumatic system. It could be an electric system, but it happens to be a pneumatic system. It's the same either way. So typical situation, utility failure, and then one of the generators maybe is in maintenance, or maybe it fails to stop. It's not that unusual, about 1% failed to start. Maybe running for as well, and the second generator fails. Now, depending on the load, at that point you lose the entire critical load. But it's avoidable under one scenario, which is if you're prepared to disconnect part of the critical load to save the remainder of the critical load. It's not a system which is implemented widely, but it is advisable to think about a strategy for something like this, because this situation has occurred and probably will continue to occur for some time to come. Here's the next scenario, static transfer switches. So often when static transfer switches are deployed, they're deployed with isolation transformers, downstream isolation transformers. The purpose of those may be to provide a neutral, maybe to limit short circuit, maybe a number of reasons you might do that. The problem is, if you do a significantly out of phase transfer into an isolation transformer, you'll saturate its core. When you saturate its core, so the graph shows you there, the voltage at the output of the transformer, and therefore the IT load will drop to 0, and you'll lose the IT load. So the mitigation for that, well, a number of things you can do, but probably the best thing to do is to ensure that the STS has got a transfer inhibit algorithm, which prevents it from transferring above a certain phase angle. Okay? Similar like, so it's common. Oh, cyber. So when I talk to a lot of people about their data centers, and they say to me, oh, don't worry, we're air gapped. There's no problem. not going to affect us. So perhaps people aren't aware that when you buy, for example, a cooling system, very often it will come with, as part of its controls, a wireless gateway. It'll just come naturally. Whether you use it or not, it's neither here nor there. It just comes as part of the system. Not always, but often. So if you've got such a wireless gateway, and imagine the cooling system is installed on the roof of the building, which many are in Singapore, and you've got a wireless gateway that's not being used, the chances are its password will be username, and its username will be password. And basically, if you stand on the roof of an adjacent building with a high-gain Wi-Fi antenna, you will be able to access that chiller wireless gateway and program it to shut down at will whenever you want. Nobody would be any the wiser. So that's just one example. There are many other examples. So I think the wireless gateway and the controls gateway is a good one as in terms of an example, cyber example. So be aware of that. Now we're going to talk about tap-off units. Now the industry is crazy busy, right? With huge amount of data centers being built around the world. And I don't know if you've noticed, but we've certainly noticed there's been a drop-off in terms of equipment integrity. In other words, production-related issues are some equipment. A lot of this you can look at and resolve at a factory acceptance test, but you're not going to factory test everything. And probably you're not going to factory test your tap-off units. So arc flash is becoming an increasing problem. As most of you know, the impact of arc flash could be quite severe. We've seen 3 instances in the last 6 months. That's just us. And 2 of which where some people have been very badly burnt. So the mitigation for this, well, there's not much you can do about the equipment failure, really. But certainly, whenever somebody's working with live tap-off unit, consider the BPE. A lot of people don't think that's necessary, but I believe it is because of these high instances of manufacturing problems. The Swiss cheese model. So this is an old, famous business model. So just to explain the Swiss cheese, because I like talking about it. See the cheese on the left there with no holes, that's the perfect data center. It's got no design error. It's got no commissioning errors. It's got no defects or latent defects. It's the perfect data center. So no matter what happens, that data center won't fail. The cheese on the right with the holes in it represents a more realistic type of data center environment. And our job as engineers and data center owners is basically to prevent the risks, which are the arrows, penetrating the holes and causing an outage. But you'll never have a perfect data center. Even if you were able to design it perfectly, commission it perfectly, and operate it perfectly, you still have incipient faults. In other words, equipment faults that have developed over time. So you'll never have that perfect scenario. So this is where EOPS are so important, emergency operation procedures. And, I think a lot of organizations just don't have these. What happens if I'm about to go into a very serious situation where the data center will fail within a few minutes or relatively soon? What can we do? How do we react? So every data center needs to look at, through its FAMIR assessment, what those risks are and what steps can be taken from an EOPS point of view to prevent outage. And then finally, categories. And as I said, this isn't anything for you engineering guys to worry about, but this is amazingly common. So, you read about data center outages in the press. And of course, more often than not, they don't tell you what the cause was for one reason or another. Quite a lot of them are a result of the inappropriate use or the inappropriate configuration of software. So what we've got here is basically 2 data centers, remote from one another, both carrying out the same task at the same time. So in this case, it's order processing. So what should be happening is that the process should flow vertically down through both of those stacks, both of those data centers. One is active, the other one is also active, but as a backup. And you get to the bottom, so you go right the way down through the stack, you get to the bottom, both should match. What often happens, the transgression occurs when the data centers are communicating with each other and the active application or application process is in the other data center. So the minute you lose one data center, you lose everything. Surprisingly common. Speed to market, I have a real problem with that. It's not, I understand it's unavoidable, but all that does in reality is drives up error rates. Surely, I mean, the faster you're forced to do something, particularly if it's beyond what you think is a reasonable amount of time, inevitably it's going to increase the amount of errors, right? I'd recommend that you carry out a failure mode and effects analysis. It's a tedious and lengthy task, but at least you get status. You understand, what the risks are, and gives you an opportunity to mitigate those risks. Always carry out a cyber assessment, and the other bit of advice is to develop comprehensive SOPs, standard operating procedures, maintenance operating procedures, and emergency operating procedures. So that's it from me. Thank you for listening.
Thank you, Ed, for that insightful presentation. The Singapore Cloud and Data Center Convention 2024 was a key part of the Sijori Week. Sijori represents the special economic zones between Singapore, Johor, and Riau Islands, specifically Batam. This week also featured an industry golf tournament, Interconnect World events, business mission trips to Batam and Johor, and numerous networking parties. Following its inaugural success, we are thrilled to announce that the next Sijori Week will be held from 6th to 10th July 2025. To be part of next year's event, reach out to the W Media team. Thank you for joining us on this incredible journey. We look forward to seeing you next year.